Hello children, how are you all? I hope you are doing well and I heartily welcome you all for the Samveda e-learning program. My dears, from the last two sessions you are learning the chapter 10 light, reflection and refraction. Today also you are going to learn few more concepts of the lesson. Before going to that, we shall recall what we have learnt in the previous class. My dears, we have learnt about image formation by spherical mirrors and also we learnt ray diagrams for the formation of image by concave mirror, uses of concave mirror, image formation by a convex mirror and its uses, and at the end we have discussed about mirror formula and the formula used to calculate the magnification. You are going to learn following concepts today: refraction of light through rectangular glass slab, refractive index and spherical lenses. A picture based question I have asked in the previous class. I hope you have all written correct answer. Check your answer. The question is like this. Look at the picture and answer the question. The first question is, what is the type of the mirror that produced the image of the doll's face? The next question I have asked, what is the reason for the formation of a large image of doll's face? And the third question I have asked is, write the medical applications of this type of mirror. The answer for the first question is concave mirror, since it is producing enlarged image and a virtual image, and here we have got the magnified image or enlarged image of the doll because the doll is placed between F and P. And answer for the third question is, this type of mirrors is used in dental checkup since it is going to give a magnified image. It is useful to check the faults of the teeth because it produces a large image. My dear students, I am going to show some videos which are related to the today's concepts, and you have to observe carefully and you have to give the reason for the result what we have obtained in the video. Look at the video carefully. See what is happening there. Water is pouring inside the beaker having pencil, and observe carefully there where the water and air is going to be interface. What you have noticed? I think you may have question in your mind, why pencil partially immersed in water in a glass tumbler or a beaker appears to be displaced or bent at the interface of air and water. Look at the one more video. Here coin is placed at the bottom of the beaker. Here also water is pouring inside the beaker. Observe carefully. See the position of the coin with respect to the water. What you are seeing there? Yes, you are correct. The coin appears to be raised. Here also you have a question in your mind, why coin is placed at the bottom of a beaker containing water appears to be raised. You might have seen in your home a lemon placed inside the glass containing water appears to be bigger than its actual size. What is the reason for this? Can you tell me the reason for this? Reason for all these situations is refraction of light. My dears, today you are going to learn another important property, that is refraction of light. It is a bending nature of light when it is travel from one medium to another medium. Before going to know more about refraction of light, let us learn the meaning of refraction of light. Refraction of light is nothing but when light travels obliquely from one transparent medium to another, it gets bent. This bending of light is called refraction of light. You are seeing in this video, here the ray of light is traveling from one medium to another medium obliquely, and you are seeing the bending of the light. Now let us learn how the refraction is going to be takes place through glass slab. So here I am showing you video. This is how refraction is going to be takes place when ray of light traveling from air medium to glass medium. See how the ray of light is bent inside the glass slab. And if there is no glass slab, what will be the path of the light? Yes, you are correct. It always travels in a straight line. So this is how refraction is going to be takes place in a rectangular glass slab. Let us learn the terms associated with the refraction of light through a glass slab. My dear students, the ray of light which is going to be travel from air medium to glass medium is called as an incident ray, and there we have drawn a perpendicular, that is we have drawn perpendicular at the point of incidence is called as a normal, and the angle between the normal and the incident ray is called as angle of incidence. Then, so after getting into the glass slab, it is going to be refracted. So this ray is called as refracted ray, because it is going to be bent because it is traveling from one medium to another medium. So here the angle between the normal and the refracted ray is called as angle of refraction. So that dotted line indicate the actual path of the light which is going to be travel if there is no glass slab. So here the ray of light again is going to be refracted, because the ray of light now entering from glass medium to air medium. See, this ray is called as emergent ray, and angle between the emergent ray and normal is called as angle of emergence. You can notice the bending nature of the light when it is travel from air medium to water medium. You can conduct this experiment at your home with the help of a laser torch and a glass jar containing water. You have to note this point, my dear student. When a ray of light passes through a rectangular glass slab, what you have noticed? Yes, you have noticed that it gets bent twice at the air glass interface and at the glass air interface. So for the first, the refraction is going to be takes place from air medium to glass medium, and the second time when the ray of light traveling from a glass medium to air medium, again it is going to be refracted. So that is why refraction takes place twice in case of glass slab. And also you have to note that emergent ray is parallel to the incident ray and is displaced through a distance. My dear student, depending upon the velocity of the light in the medium, we are going to name the medium as a rarer medium and denser medium. Optically denser medium means it is the medium in which speed of the light is less, that is water. If you are consider air and water, the optical density of the water is more, that is why it is called as denser medium. Optically rarer medium means the medium in which the speed of the light is more, that is in air, if you have considered air and water as a medium. That means between air and water medium, the velocity of the light is more in case of air, that is why that air medium is called as rarer medium, and velocity of light is lesser in water, that is why it is denser medium. And you also note that the denser and rarer medium do not depend upon the density of the medium, it is only depend upon the velocity of the light. Now, note these points, my dears. When ray of light travelling from air medium to glass medium, see the nature of the refracted ray, it is bent towards the normal. See, if you are going to compare the incident ray as well as the refracted ray, it is bent towards the normal. What happens if the ray travelling from denser medium to rarer medium? It is going to be bent away from the normal. See, you can compare incident ray as well as refracted ray. So, here the ray of light travelling from denser medium to rarer medium, that is glass medium to air medium, the ray of light bending away from the normal. Yes, in the previous case you have noticed that when the ray of light travelling from rarer medium to denser medium, it is going to be bent towards the normal. So, these are the two important things you have to notice regarding refraction of light through a glass slab. Based on the nature of the refracted ray, we have two laws of refraction. The first law of refraction says the incident ray, the refracted ray and the normal to the interface of two transparent media at the point of incidence all lie in the same plane. So, you can see over here there is a incident ray and there is a refracted ray and there is a normal. These three lie on the same plane. This is the statement of the first law of refraction. Remember again, the incident ray, refracted ray and the normal drawn at the point of incidence all are lie on the same plane. Let us come to the second law of refraction. The second law of refraction says the ratio of sine of angle of incidence to the sine of angle of refraction is a constant for the light of given color and for the given pair of media. I am repeating again, the ratio of sine of the angle of incidence to the sine of the angle of refraction is a constant for the light of a given color and for the given pair of media. This law is also called as Snell's law. This law is true for the incident angle between 0 and 90 degree. This law is valid only the angle of incidence is between 0 degree to the 90 degree. Here if the I is the angle of incidence and R is the angle of refraction, then we can simplify the second law of refraction like this: sin I by sin R is equal to constant. So, this is the relationship between sine of the angle of incidence to the sine of the angle of refraction. So, this constant is called as refractive index. This refractive index measures speed of the light in two different medium. You can understand the second law like this. Here there is an angle between the incident ray and the normal, that is angle of incidence, and here it is an angle, that is angle of refraction, it is between refracted ray and the normal. So, according to the second law of refraction, the sin I by sin R is equal to constant. It is valid for the value of I between 0 degree and the 90 degree. Now, let us learn about refractive index. I already told you refractive index or index of refraction measures the bending of the ray of light when it is passing from one medium to another medium. So, that measures the bending of a ray of light when passing from one medium into another. Now, let us learn some more about the refractive index. Let us consider a ray of light travelling from medium 1 to medium 2, say for example, air medium to water medium. Let V1 be the speed of the light in medium 1 and V2 be the speed of the light in medium 2. The refractive index of the medium 2 with respect to the medium 1 is given by the ratio of the speed of the light in medium 1 and the speed of the light in medium 2. So, this is represented by the symbol N21. This is expressed in an equation like N21 is equal to speed of the light in medium 1 and speed of the light in medium 2, which is also going to be written as V1 by V2. So, this indicates the speed of the light in medium 1 with respect to the medium 2. You also know about absolute refractive index. The absolute refractive index is also called as refractive index, which is going to be measured by taking any one of the medium as a standard one. Here, if the medium 1 is vacuum or air, then the refractive index of the medium 2 is considered with the respect to vacuum. This is called absolute refractive index of the medium. It is simply represented as N2. My dears, if c is the speed of the light in air and v is the speed of the light in the medium, then refractive index or absolute refractive index of the medium Nm is given by speed of the light in air divided by speed of the light in medium, which is equal to c by v. Here the absolute refractive index of the medium simply called it as a refractive index. So, we have calculated refractive index, that is absolute refractive index for some materials. Absolute refractive index of air is 1.0003, that of Canada balsam is 1.53, ice is 1.31, water is 1.33, rock salt 1.54, alcohol 1.36. Absolute refractive index of the diamond is 2.42. So, if you are going to compare this data, you come to know that air having the least absolute refractive index and diamond having the maximum refractive index. Here, when compared to air and the diamond, air medium is called as rarer medium and diamond is called as denser medium. And much more interesting concept about these things are velocity of light is more in case of air and which is less in case of diamond. So, when ray of light travelling from air medium to diamond medium, the velocity of the light is going to be changed or reduced. My dear student, I have a question for you. The refractive index of water is 1.33. What is the meaning of this statement? Can you tell me the meaning? Yes, let us know the meaning of this statement. This means that the ratio of the speed of the light in air and the speed of the light in water, which is equal to 1.33. Can you try yourself? You have to write the meaning for these two statements. The refractive index of crown glass is 1.52. What is the meaning of this statement? So, this crown glass are going to be used in the construction of optical devices like lenses as well as mirrors. The refractive index of diamond is 2.42. What is the meaning of this statement? You have to write the meaning for these two statements. In the previous sessions, you have learnt about spherical mirrors. Today, you are going to learn about spherical lenses. You know that spherical mirrors, depending upon the reflecting surface, you have classified them as a concave mirror as well as a convex mirror, and you have learnt the ray diagram associated with the mirrors and also their uses. So, similarly, we have definitions for spherical lenses. A spherical lens is a transparent material bounded by two surfaces, one or both of which are spherical. You have seen convex as well as concave lenses at your school in your science lab. So, what you have noticed there? You have noticed that their surfaces are bulged, their surfaces are curved. What is the difference between the spherical lenses and the mirrors? The spherical mirrors they are not the transparent material, they are going to reflect the light. Reflection is going to takes place in the mirrors, but where in case of lenses, refraction is going to takes place. These are the transparent material. Ray of light is traveling from one side to the another side. You are going to learn all those things in detail. So, based on their spherical surfaces or curved surfaces, we have classified spherical lenses mainly into convex lens as well as concave lenses. Now, let us learn the meaning of convex lens. A convex lens is a thicker in the middle and thinner at the edges. Convex lens will be thicker in the middle and thinner at the edges. Ray of light parallel to the principal axis after refraction through a convex lens meet at a point that is going to be converge on the principal axis. Here the convex lens thicker at the center and thinner at the edge, these lenses are going to converge as the rays of light. And we can draw the ray diagram for the convex lens like this. Here the rays of light parallel to the principal axis, after refraction they are going to meet at a point that is called as principal focus, that is capital F. And you know that the distance between the optic center to the principal focus will be the focal length. You have learned the same terms in mirrors also. Now, let us know about concave lens. It is quite opposite to the meaning of the convex lens. Concave lens is thinner in the middle and thicker at the edges. Here, concave lens diverges the rays of light, that is, ray of light parallel to the principal axis after refraction get diverged and appear to be come from a point on the principal axis on the same side of the lens, and you can notice the divergence of the concave lens. Here the ray which is parallel to the principal axis, after refraction they are going to be diverged. So, we can draw the ray diagram like this. Now, so we have also different types of concave as well as convex lens. In case of convex lens, if the two faces are or two surfaces are bulged like this or curved like this, it is called as biconvex lens. If one side is plane and another side is curved, then it is called as plano-convex, and if it is like this, that is meniscus convex lens. In case of concave lens or diverging lenses, if two surfaces are curved like this, then it is called as biconcave lens, and it is like this, it is called as plano concave, and it is like this, meniscus concave. So, based on the surface we are going to name the convex as well as concave lenses. So, we have the difference between concave lens as well as convex lens like this. Convex lens is thicker in the middle and thinner at the edges, and it is also called as converging lens, where in case of concave lens it is thinner in the middle and thicker at the edges, it is also called as diverging lens. My dear student, you have learned many important concepts about the lesson in the today's class. Let us recall what we have learnt in this session. My dear student, you have learnt about refraction of light. What is the definition for the refraction of light? Yes, you are all capable to recall the definitions of the refraction of light. Just remember it again. When light travels obliquely from one transparent medium into another, it gets bent. This bending of light is called as refraction of light. You also learnt about optical denser medium and optical rarer medium. Optical denser medium means the medium in which the speed of light is less, that is example for this denser medium is water, and optically rarer medium is nothing but the medium in which the speed of the light is more, that is air medium is called as rarer medium. And you should remember this thing, the denser and rarer medium do not depend upon the density of the medium, it depends upon the velocity of the light in the medium. And also you have learnt about laws of refraction. The first law of refraction says that incident ray, the refracted ray and the normal to the interface of true transparent media at the point of incidence all lie in the same plane. And also you have learned the second law of refraction. In the second law of refraction, or the statement of the second law of refraction is the ratio of sine of the angle of incidence to the sine of the angle of refraction is constant for the light of a given color and for the given pair of media. So, mathematically we have written as sin I by sin r is equal to constant, where I is the angle of incidence and r is the angle of refraction. And also you have learnt about the refractive index. It is the measure of the bending of a ray of light when passing from one medium to another medium. Now, you also learned that when ray of light travel from a rarer medium to a denser medium, it bends towards the normal. And also you have learned that when light ray travel from denser medium to rarer medium, it is bends away from the normal. You also learnt about convex lens and concave lenses. You know that convex lens is a lens which is thicker in the middle and thinner at the edges. It is going to be converges the ray of light. And about concave lens also you have learned. A concave lens is thinner in the middle and thicker at the edges. It is going to be diverges the rays of light, that is why it is called as diverging lens. My dears, I have a question for you. If we submerge the lens in water, will the focal length of the lens change? Think it over, find the answer. And now you have a questions for the home assignment. I request you to write down the questions and you have to write the answer and you have to show to your teacher. The first question is, what is refraction of light? The second question is, state the laws of refraction of light. Third question is, define refractive index. Fourth question is, write the differences between concave lens and convex lens. The fifth question is, the stick if immersed in water appears to be bent, give reason. And the last question is, why does a ray of light bend when it is travel from one medium to another? So, these are the questions for the home assignment. You have a activity, do it and know it. Conduct an activity to confirm refraction is not possible in the same medium. You have learned that refraction takes place only when the ray of light travels from one medium to another medium, and you have to confirm that refraction is not possible in the same medium or in the only one given medium. Thank you all my dear students for the nice participation in the class. We shall meet in the next class. Till then, stay safe, keep learning, and I wish you all the best. Thank you so much.